is one of the most commonly used connectors in the telephone network with coaxial cables. It is reliable, relatively inexpensive, and easy to assemble. There are many different BNC connector designs. The interfacing parts of the male and female connectors are standardized since most suppliers conform to a military specification. However, the part of the connector that interfaces to the cable can differ significantly between suppliers. Lack of standardization in the cable interface area has created confusion and uncertainty in assembling the connectors to cable. As a result, the completed assembly may be unreliable, resulting in service outages to customers. Service outages in the telephone network can affect thousands of telephone customers. Whenever a cable opens or shorts, it can disconnect the customer for extended periods, or at the very least cause noise on their circuits, which is very disruptive to them. Unlike the electronic transmission equipment, the cables are not usually protected against failures. Therefore, the customer's service is out for as long as the cable defect is present. Also, when the defective cable is located, there is no easy way to patch service off. Replacing or repairing defective cable is very time-consuming and disruptive to service. Usually, when a customer's telephone or data service is disrupted, they demand a financial credit for the disconnected calls or for the lost time. This represents lost revenue for the telephone companies, as well as a poor reflection on their quality. SBC has developed a family of BNC connectors, cables, and application tooling that meets rigorous performance standards. This video will describe the family of BNC connectors, the installation kit, and the proper method for installing a BNC connector on Lucent 734 and 735 coaxial cables. The basic components of a BNC connector are the body, the center pin, and the crimp sleeve. For a given cable type, the end of the body that connects to the cable varies dependent on which cable is used. The connector bodies have a broached pattern on them to ensure positive retention with the cable braid and the outer crimp sleeve. This family of connectors is identified by the color of the instruction cards or a bag included with the connector. Blue identifies connectors for 734 cable, while red identifies connectors for the 735 cable. The Newhall Pacific Toolkit Part NEW 100110 contains the tools necessary for proper installation of SBC-specified BNC coaxial connectors. The toolkit contains a center pin hand crimping tool, a pin crimp go, no-go gauge, a hex crimp hand crimping tool, a die set for 734 and 735 cables, a 734 hex crimp gauge, a 735 hex crimp gauge, a center pin depth gauge, a cable stripper for 734 cable, and a cable stripper for 735 cable. To assemble the connector, first slide the crimp sleeve on the end of the cable. Be certain that the step is located away from the cut end. Then strip the end of the cable to the proper length. Crimping is the only acceptable method for applying the center pin to the conductor. Be sure the pin is butted against the dielectric. The pin is then inserted into the connector body with the braid formed over the outside of the support sleeve on the body. A slight tactile response can be felt when the pin is fully seated. The crimp sleeve is then slipped over the braid and crimped in place. The detailed sequence of assembly is as follows. Slide the outer crimp sleeve on the end of the cable. The step at the end of the sleeve must be facing away from the connector body. The cable must be stripped to the proper length. The NEW 100113 power stripper may be used with the correct cutting head for the cabling being used. This demonstration will be done with the power stripper and 735 cable. Place the automated stripping unit into the AC power pack. Place the cutter head into the stripper unit. Install the cover. Insert the cable into the cutter head and hold it for a minimum of 4 seconds. Remove the scrap ends by grasping them with your fingers and with a twisting motion pull them off. The cut portions of dielectric, foil, and braid should cleanly separate from the cable. Check the depth of the cuts. Be sure that the center conductor and braid wires are not nicked and that the dielectric is not excessively scored. Assure that the center conductor length is the required 7/32 of an inch. All stripped cable lengths can be verified with the outline on the package or instruction card. Prior to daily use, the center pin crimp tool must be checked to verify the crimp diameter. This is done using the go, no-go gauge. Now the center pin must be attached to the center conductor. All pins must be crimped to the center conductor. The NEW 100-103 crimping tool must be used. This tool makes a triple dimple crimp on the pin. Other center pin crimping tools may be available, but the NEW 100-103 tool is the only center pin crimping tool certified for use by SBC on these connectors. Just because a crimped pin appears to be firmly attached to the conductor does not mean that it will be electrically stable for a long time. It is imperative that the correct tool is used. To crimp the center pin, first be sure that the proper pin is used with the selected cable. This is critical because the hole in the pin is sized for each cable wire gauge, and these dimensions are critical in achieving a reliable crimp. Slide the pin onto the center conductor until it is flush with the dielectric. Insert the pin into the crimping tool and close the tool completely. The tool handles are controlled by a full cycle ratchet and must be fully closed before they will release. Examine the completed crimped pin for uniformity of indents in the crimped area, and be sure the pin is flush against the dielectric. There must be 4 sets of 3 indents uniformly spaced around the center pin. If the indents in the pin are not uniform or appear abnormal, a new tool must be obtained. Do not continue to use this tool as the reliability of the terminations and the customer service is in jeopardy. Fan out the braid slightly and push the center pin into the body of the connector. The pin must snap lock into place and resist a slight tugging action. This lock assures proper positioning of the pin in the connector. On 734 and 735 cables, the foil shielding must go inside the connector body along with the dielectric. Neatly dress the braid uniformly around the outside of the connector body and slide the crimp sleeve over the braid. Select the correct crimping die. It is important to remember that the hex crimp tool must be verified daily before use using the hex crimp gauge. For traceability, the die faces are inscribed with the serial number. This inscription leaves an imprint in the crimp sleeve that allows each termination to be traced to a specific installer. Carefully locate the crimping tool around the sleeve with one edge against the connector body. The dies are 1/2 inch wide, which is the same length as the sleeve. Completely close the crimping tool and release it. The tool has a ratcheting mechanism that requires that the tool be completely closed before it will release. The crimp sleeve will now be hex-shaped, firmly bonding the cable braid to the connector body. The ends of the crimp sleeve have a step on the end away from the connector body to provide a finished appearance and to help retain the cable jacket under the crimp sleeve when the cable is bent close to the connector body. On the BNC connectors, the center pin depth relative to the connector end must be measured. The pin depth is important to ensure proper engagement with the mating contact. The pin depth is determined by a ridge inside the connector body and a groove cut into the pin. Pins that are too long can damage the mating jack, and pins that are too short may not make stable contact. To ensure that the pin is correctly seated, use the NEW 100-104 center pin go, no-go depth gauge. The go end of this gauge has a 0.03 of an inch step on the end, and the no-go end has a 0.40 of an inch step on the end. When passing the go end of the gauge over the end of the connector, the center pin should not touch the gauge. When passing the no-go end of the gauge over the end of the connector, the center pin should touch the gauge. If the connector fails either of these tests, then the pin is incorrectly installed and the connector should be cut off and the cable re-terminated with a new connector. It is important to remember that the hex crimp tool must be verified daily before use using the hex crimp gauge. The contact crimp tool must be verified daily before use using the go, no-go gauge. Field verification must be performed each day. If any hand tool fails to pass the go, no-go test, consult the factory for replacement instructions. Traditionally, field testing of a cable assembly consists of checking for continuity or shorts. This can be accomplished using the NEW 100-114 continuity tester. It is strongly recommended that installers perform a transmission test along with a physical exercise of the finished termination. Intermittent cable terminations have been a significant cause of service outages in the transmission network. The time to find intermittents is before service is applied. They can be repaired while the installer is still on premise. The suggested method for doing this is shown here. Apply a continuity tester signal from a test set to the newly installed cable assembly. Provide a loop back on the cable being tested. Connect the continuity tester to the return cable. Now physically flex the cable at all the new connectors, including splices, and check the test set for errors. Flexing the cable 15 to 20 degrees in all directions and a slight tug and compression on the cable jacket is all that is required to be reasonably confident that a connection is reliable. This technique is not a 100% guarantee, but it is a reasonable representation of the forces that a cable assembly will encounter in normal handling. If errors are observed on the test set, then something is intermittent or improperly assembled, and the cause must be located. By testing cable assemblies in this manner, potential future problems are isolated while the cable installer is still on site, allowing the problem to be fixed before the cables are turned over to the customer. A good rule of thumb with this test is, if in doubt about the integrity of a connector, replace it. It's better to replace a faulty component worth a few dollars than to risk the loss of service worth hundreds or thousands of dollars. It has been the goal of this video to provide instructions on the proper installation of SBC BNC connectors. With the use of the Newhall Pacific tool